Hi, this is GCSE 9 to 1 Crammers. It's never too late to start revising, and this way you can do it anywhere. Test yourself by stopping the video after each question. Have a go at answering it and then play on to check it. Run through the questions as many times as you need until the answers pop into your head. Today we're revising Physics, Topic 4, Nuclear Fission and Fusion, and we'll be covering nuclear fission, nuclear fusion, nuclear power stations, irradiation, contamination, and background radiation. Nuclear fission. Describe the process of nuclear fission. An atomic nucleus absorbs a neutron, fission happens and the nucleus splits into two smaller nuclei, releasing 3 neutrons and energy. For example, uranium undergoes nuclear fission and splits into a krypton nucleus and a barium nucleus. What must usually happen before a nucleus will undergo nuclear fission? The nucleus must absorb a slow-moving neutron, making the nucleus unstable enough to split. Explain how a nuclear fission chain reaction can happen. When the nucleus splits, releasing 3 neutrons, then if these neutrons are absorbed by another nucleus, they cause more fission to happen. This is a chain reaction. For the exam, know how to draw and label a diagram showing a chain reaction. The picture below shows the nucleus of an atom of uranium-235, U-235, about to undergo nuclear fission. Before nuclear fission can happen, the nucleus of a uranium atom has to absorb the particle labelled X. What is particle X? It's a neutron. Nuclear fission power stations. Describe how nuclear energy is used to generate electricity. Do not explain the nuclear fission process. Nuclear fission uses fuels like uranium or plutonium that releases energy to heat water, turning it into steam, which drives turbines. The isotope molybdenum-99 is produced inside some nuclear power stations from the nuclear fission of uranium-235. Inside which part of a nuclear power station would molybdenum be produced? In the nuclear reactor. The diagram below shows the cross-section through a nuclear reactor. Explain why lowering the control rods reduces the amount of energy released each second from nuclear fuel. Control rods are made from boron, which are used to control the chain reactions. Boron atoms absorb neutrons without undergoing nuclear fission, which slows down the chain reactions because there are fewer neutrons. The diagram shows the nuclear fission process for an atom of uranium-235. Complete the diagram to show how the fission process starts a chain reaction. You'll need to show the neutrons hitting each other, U-235 nuclei. Then show each of the U-235 nuclei splitting to produce another Xe-140 and Sr-94. And 2 more neutrons, etc., etc., etc. The chain reaction goes on. Plutonium-239 is one substance used as a fuel in a nuclear reactor. For nuclear fission to happen, the nucleus must absorb a particle. Which type of particle must be absorbed? A neutron. What are the advantages of nuclear fission reactors used in power stations? Nuclear fuels like uranium and plutonium are fairly cheap. Nuclear power is clean. It does not produce any harmful gases or chemicals that can go into the environment. What are the disadvantages of nuclear fission reactors used in power stations? The startup costs of nuclear power stations are very high. They take the longest time of all power stations to start up. Energy produced from fission produces dangerous radioactive nuclear waste. The radioactive nuclear waste is difficult to dispose of because it stays radioactive for a very long time and needs to be stored safely away from people's homes. Transporting nuclear waste does cause a small amount of pollution from lorries burning fossil fuels. Decommissioning a nuclear power plant is expensive because it must be made safe for people and the environment. Equipment failure in the power station could lead to a major disaster, for example the Chernobyl disaster in 1986 or the Fukushima disaster in 2011. Nuclear fusion. Explain what happens in the process of nuclear fusion. Two nuclei collide at high speed and fuse together to create a larger, heavier nucleus and releases lots of energy. Nuclear fusion also releases energy. Nuclear fusion happens at very high temperatures. A high temperature is needed to overcome the repulsion force between the nuclei. Why is there a repulsion force between the nuclei of atoms? Because the nuclei are positive and have the same charge. Where does nuclear fusion happen naturally? In stars. When a nuclear fusion reaction happens, it generates the energy that keeps them hot and bright. Nuclear fusion power stations. Describe how nuclear energy is used to generate electricity. Do not explain the nuclear fusion process. The nuclear energy released heats water, turning it into steam, which drives turbines to generate electricity. Explain how nuclear fusion reactors are used in power stations. Nuclear fusion uses isotopes of hydrogen, called deuterium and tritium. Deuterium can be easily extracted from seawater. Tritium can be produced from lithium, which is also found in seawater. The advantages of using nuclear fusion: seawater is available in very large amounts. It is easy to obtain and extract, and energy produced from fusion produces very little radioactive waste. The table below shows the energy released from 1 kilogram of fusion fuel and from 1 kilogram of fission fuel. List the advantages of the fuel used in a fusion reactor compared with the fuel used in a fission reactor. Looking at the table, we can see that fusion releases more energy from 1 kilogram of fuel than fission. Now list the other advantages you know. The isotopes of hydrogen are easily extracted from seawater. Seawater is easy to get and is readily available in large amounts to use. The energy produced from fusion produces very little radioactive waste. However, nuclear fusion on Earth has not proved possible because of the extreme temperatures required, at least 100 million degrees Celsius, 6 times hotter than the Sun. And scientists have not been able to achieve cold fusion either. Some scientists think that by the year 2050, a nuclear fusion power station capable of generating electricity on a large scale will have been developed. Suggest the important consequence of developing nuclear fusion power stations to generate electricity. It's a sustainable source of available electricity that is less damaging to our environment, and it helps to reduce the use of fossil fuels used, while trying to increase electricity supply to meet demand. Irradiation and contamination. Contamination or irradiation can cause different amounts of harm to the body based on the radiation type. Irradiation is being exposed to radiation. The most dangerous ionizing radiation outside the body is beta and gamma rays, as they mostly pass straight out the body. Because they have a lower ionizing power, this means the smaller beta particles and gamma rays don't bash into lots of atoms, so they don't create as many harmful ions compared to alpha particles. They are not slowed down and can travel quite far. Because of this, beta and gamma rays are used in medical emitters. Contamination is the presence of radiation atoms in or on something. The most dangerous ionizing radiation inside the body is alpha radiation, because it does damage in a localized area, and is highly ionizing, because they're big, so bash into lots of atoms, knocking off electrons. then slowing down, creating lots of harmful ions, and because of this are not used in medical emitters. What is meant by the term irradiation? Irradiation is when something is exposed to radiation from a radioactive source, but they don't become radioactive. Exposure to radiation can damage or kill healthy cells. Which types of ionising radiation are most dangerous outside the body? Beta and gamma rays are the most danger outside the body because they can penetrate the body and get to our organs, killing healthy cells. Beta and gamma are the most dangerous types of radiation from high levels of irradiation exposure. What is meant by the term contamination? Contamination is where unwanted atoms of a radioactive substance get into or on a material. These contaminated atoms then start to decay, damaging and killing healthy cells. Which types of ionising radiation are most dangerous inside the body? Alpha is most danger inside the body. It does damage in a localized area, killing healthy cells, and is highly ionising. Because alpha particles are big, they bash into lots of atoms, knocking electrons off them, before slowing down, which creates lots of ions. What precautions can be taken to minimise the risk of contamination? Wear gloves to stop particles getting stuck on your skin or under your nails. Keep saucers in lead-lined containers. Use tongs when handling saucers. Wear protective suits to stop breathing in particles. Stand behind a screen or in another room when operating X-ray or CT machines. Objects near a radioactive source are irradiated by it. Explain what is meant by this. Irradiation is when something is exposed to radiation, but they don't become radioactive. Exposure to radiation can damage or kill healthy cells. Background radiation. Name 3 sources of background radiation. Naturally occurring unstable isotopes, for example in the air, food, building materials and rocks like granite, especially if they release radioactive radon. Cosmic rays are radiation from space, for example the sun. Luckily, the Earth's atmosphere absorbs a lot of the radiation from cosmic rays, but if you live at high altitudes, you'll be exposed a lot more. Man-made sources, for example nuclear weapons, nuclear waste and nuclear disasters like Chernobyl. You are likely to get exposed to a lot more radiation if you work in the nuclear industry. What is meant by isotopes of an element? Atoms with the same number of protons but a different number of neutrons in their nucleus. What is a dose of radiation measured in? Sieverts. What is a background dose of radiation measured in? Millisieverts. 1 sievert is equal to 1000 millisieverts. Some types of job increase the radiation dose a worker receives. People working as aircrew receive an increased radiation dose due to flying at high altitude. The radiation dose from which source of background radiation is increased by flying? Cosmic rays. The following table gives the average additional radiation dose received by aircrew flying to various destinations from London. What is the relationship between flight time and the average additional radiation dose? The longer the flight time, the greater the dose. The following table gives the effects of different radiation doses on the human body. Explain whether the business person should be concerned about the additional radiation dose received during long flights. They should not be concerned, because the additional dose is very small and is well below the dose that may cause cancer. The key to exam success is learning consolidation and keeping this topic fresh in your mind to nail those questions in the Physics GCSE Paper 1 exam. If you go over this enough times, you'll be able to answer any questions on this topic confidently in your exam. This is GCSE 9 to 1 Crammers, and if you like the content of this video, give us a thumbs up. And if you have a question or need help, give us a comment below. And don't forget, smash that subscribe button if you want more Crammers videos for your exam success. Thanks for watching, and see you again soon.